It is the most expensive weapon system ever built. The unseen predator of the sky.
A $100 million ghost that can break the sound barrier without ever being detected.
But before it disappears from radar, it appears here, the world's most advanced manufacturing facility. It doesn't start with heavy steel, but with rolls of classified black carbon fiber weave. Laser projectors map the fuselage shape. Human hands are too imprecise for true stealth. Automated fiber placement machines spin layers of composite material with microscopic accuracy. The fuselage skin is built up layer by layer, creating a single, seamless, fastener-free shell. The soft parts are sealed in vacuum bags and pushed into a massive autoclave oven. High heat and pressure fuse the fabric into a material stronger and lighter than titanium. It emerges as a single solid piece, smooth to the touch and invisible to enemy radar. Beneath the stealth skin lies the backbone, massive bulkheads carved from solid titanium billets. These structures must survive 9G maneuvers that would crush a human pilot. Traditional welding is too messy. We use high-energy electron beams in a vacuum chamber. In the void of the vacuum, a concentrated beam of electrons melts the metal without touching it. The result is a joint perfectly fused at the molecular level, indistinguishable from a solid piece. The forward fuselage is mated to the wings using laser-guided alignment systems. Robotic drills bore thousands of holes for the fasteners that hold the skeleton together. Each hole is countersunk perfectly. A screw head sticking out by a millimeter would ruin the stealth. It disappears completely into the surface. The wings are not just for lift. They are fuel tanks, carrying thousands of pounds of kerosene. Lasers scan every inch of the airframe. Any imperfection is flagged and rejected immediately. Now, the beating heart. The Pratt & Whitney F-135, the most powerful fighter engine ever built. The turbine blades are not cast. They are grown as single crystals in a vacuum furnace. This single crystal structure allows them to survive temperatures hotter than molten lava without melting. The rear nozzle is a mechanical marvel. The three-bearing swivel duct allows thrust vectoring. A robotic cradle slides the massive engine into the rear fuselage millimeter precision. The engine is pushed slowly. For the vertical takeoff model, a massive lift fan is installed behind the cockpit.
A carbon fiber drive shaft connects the main engine to the fan, transferring 29,000 horsepower.
When engaged, doors open above and below, turning the jet into a hovering rocket.
The rear nozzle rotates 90 degrees down, balancing the aircraft on pillars of screaming fire.
Together, they generate 40,000 pounds of vertical thrust, defying gravity itself. The canopy is a seamless bubble of aerospace-grade polycarbonate, baked for days to optical perfection. A microscopic layer of gold and indium tin oxide is vacuum deposited onto the glass. This gold shield traps radiation and prevents the pilot's helmet from reflecting enemy radar signals. The cockpit is lowered in. There are no analog gauges here, just a single panoramic touchscreen. The pilot connects to the machine, not with a joystick, but with a $400,000 helmet. 6 infrared cameras distributed around the jet stream video directly to the pilot's retinas.
This allows the pilot to look down through the floor and see the ground below. X-ray vision is real.
In the nose, the AESA radar is installed.
It contains 1,000 tiny transmitter modules.
It can jam enemy electronics, fry sensors, and map the terrain simultaneously.
Under the chin sits the electro-optical targeting system, a diamond-shaped window of sapphire glass.
Now, the most classified step of all, the application of radar-absorbent material.
This is not paint. It is a complex chemical matrix designed to trap and absorb enemy radio waves.
Robots measure the coating thickness to the micron. Too thin, you appear on radar. Too thick, you are too heavy. Technicians hand-fill the final gaps with a classified putty, sealing the jet into a seamless monolith.
The jagged, sawtooth edges of the landing gear doors are designed to scatter radar waves into the void.
The jet enters a final curing oven. The coating hardens into a tough, rubberized skin.
Low visibility markings are applied. No bright colors here, just shades of lethal gray. The massive hangar doors roll back. The finished Ghost emerges into the sunlight for the first time.
On the tarmac, the beast wakes up. The engine ignition creates a localized storm.
The pilot engages the lift fan. 40,000 pounds of metal defies gravity, floating on a pillar of air.
The rear nozzle rotates up. The vertical lift turns into raw forward acceleration. Long missions require stamina. The jet drinks fuel from a tanker at 30,000 feet.
For the Navy variant, landing is a controlled crash onto a moving aircraft carrier deck.
Stealth means no missiles on the wings. They are hidden inside, waiting to drop.
If targeted, it releases a cloud of magnesium flares to confuse enemy heat-seeking missiles.
At night, the formation lights glow eerie green, like a pack of wolves hunting in the dark.
The pilot experiences 9 times the force of gravity, pushed to the absolute limit of human endurance. It pierces the sound barrier, leaving a vapor cone as the only evidence of its passing.
From a roll of black fabric to the most advanced flying machine in human history.
Invisible, untouchable, the F-35 Lightning II rules the sky.